Welcome, everyone. Today's session is on oil challenges. We have a great panel for you. I'm Amy Myers-Jaffe, and I am the David M. Rubenstein Senior Fellow for Energy and Environment at the Council on Foreign Relations, and also working with the group at Columbia University, the Center for Global Energy Policy. Marianne Ka, who is going to be our chair today, had a medical issue. Everything's fine, but was unable to attend, so I am double dutying. I am your moderator and your presenter. But we have a lively discussion for you today, and we're really looking forward to delving in. I know that at many of the concurrence sessions and other sessions, there's been some discussion about the U.S. shale boom, and so we will address that more specifically, looking at oil challenges from financial, from technical, and from geopolitical point of view. So I'm not going to read out these lengthy bios because you have a highly accomplished gentleman on our panel. I will just tell you that Michael Binnion is the founding shareholder, one of the founding shareholders of Questerre, and its chief executive officer and president of its energy corporation, and has had a long experience in banking and finance and also in energy. And Bob Kleinberg is the Senior Research Fellow at the Center on Global Energy Policy at Columbia, and also a Senior Fellow at the Institute for Sustainable Energy at BU, Boston University, and has had a long, distinguished career in the industry for many years at Schlumberger. So I think we'll start, Michael, with you, with your comments. Our format is we're each going to make a short presentation, and then we'll have some discussion, and then we'll open it up to you, the audience.
Okay. Bonjour à tous et bonjour à tous. Merci beaucoup pour cette présentation de moi. Et je vous remercie, Pierre-Olivier et Joanne, pour l'invitation d'être parmi vous pour cet discours. I want to thank Pierre-Olivier and Joanne, who invited me to discuss with you today and speak about the issue of sustainable hydrocarbons. And I'll start off by saying I'm an all-of-the-above person, and that I believe that in terms of our energy choices, that we have to make the best choice, putting the best energy in its best place as we transition our energy diet. And I think a lot of what I talk about today could be equally applied to our other energy choices, but I've been asked to speak to hydrocarbons, mostly because I'm the person who've discovered natural gas in Quebec. So why me? First of all, I'll say that there's an interesting study that I read recently about what influences people's opinions, and it turns out the number one thing is family and friends, which explains why in today's social media world is so popular, because we don't have to wait for Thanksgiving dinner anymore to find out what our family and friends think. We get to find out every day. And the second one is stereotypes. And that's, I'm influenced by, well, if you're from Texas, then it's pretty clear to me you probably wear cowboy boots. And if you're from California, you probably like to surf. And if you're an oil and gas CEO, well, you might already know what and why I'm going to say what I'm going to say here today, because I'm biased. And my Twitter profile actually says just because I'm biased doesn't mean I'm wrong. And the third one, just for completeness, was, and to give us a bit of encouragement temporarily, is scientific studies, but it turns out only the headlines, or the headline of the scientific study, which can sometimes be torqued, and also only those that confirm our existing bias. So it ends up being a little bit less encouraging than you thought at the beginning. But I do think it's important that we are careful not to marginalize through stereotypes and biases those people who actually have the most experience and knowledge about something, because it is the only way to truly understand the nuances of anything is through experience. So I personally originally thought hydrocarbons were not sustainable. My career started in the early 80s, and I went into high tech because I was 100% sure that the world would be out of hydrocarbons halfway through my career. And as you look at me, you realize that halfway through my career already happened. But I got into oil and gas into the late 1990s, and what I discovered is that oil and gas, against stereotype, is more high tech than high tech, having been in both businesses. Also, for me, I've also published a peer-reviewed paper in an international geological magazine. I've published 3 economic papers on climate policy in Canada, and I'm also led a not-for-profit. So my real interest in this discussion today is on the policy aspects of sustainability. And for me, the question of sustainable limits for hydrocarbon production, it leads, I think, to an unsustainable answer, in my opinion. And so I really want to present today the idea that we need to change the question if we're going to get a sustainable answer. And so this is the choice I'm talking about that the question leads us to, and it really is, I say, a choice between disasters. And this first chart, many of you have probably seen things like this, but I tell you, every single chart on human progress and human development looks like this one in terms of miraculous improvement in the human condition that never would have seemed possible before it happened. 1 billion people, just this one example, 1 billion people in 1800 with over 90% in abject poverty, over 900 million of them. 7.6 billion people today with less than 10% in poverty. So here we are with almost 8 times as many people, and we have less absolute, not lesser percentage, it's 10% versus 9. It's less people in poverty today than there was in 1800. But this progress has led to that rapidly increasing population, and I think probably the challenge of our times, which is to address and manage our natural environment with 12 billion people by 2100. And this chart shows the highest profile environmental challenge, and I'm sure you've seen it too, which is greenhouse gas emissions. And it is absolutely not a coincidence, these are directly tied together, that this chart is a mirror image of the other chart. The current question, in my view, leads to a choice between billions of people, not even born yet, who will be worse off because we don't manage our natural environment well, or billions of people worse off because we do manage it by cutting them off from affordable energy. So I took this from Wiki because I wanted a layman's definition of sustainability, and basically it's saying that to be sustainable, we have to meet our human progress goals while at the same time sustaining our natural environment. So it's not good enough to sustain the natural environment. You have to also sustain our human progress goals as well to be truly sustainable. People can argue this definition if you like, but I think it's common, and it's one that I certainly think makes sense. But the problem is we then have the choice of production, which will increase emissions, or no production, which will increase poverty. And so let's look at the question. And the first point I make there is we talk about sustainable limits to production, but what is production? Because even in planned economies, there is no production without demand to consume. All production starts with some demand to consume that production. Maybe art might be a possible exception to that, but in general, it's really consumption that drives production. As I tell my friends, or I tell people, you know, if people stop taking the oil out of the pipeline, I 100% promise we'll stop putting it in. So, and I think that's just a truism that's important for us to understand. Are we really talking about limits to consumption or limits to production? And then the other thing just to talk about is what is a resource, because I think this sometimes gets confused and is important to this discussion. And that is that there's many, many things that exist naturally, things that existed naturally before, that, and things that exist naturally now that could become resources in the future. So it only becomes from being something natural to being a natural resource when we have the technology and the economics to make use of it. That's when it becomes an actual resource. And technology and economics are human constructs, and they change rapidly and continuously. And just some examples in the energy area is that surface shale, tallow, whale blubber, these all used to be energy resources, but they're not anymore because of changes in economics and technology. And things like wind, hydro, swamp gas, dung, wood, they continue to be energy resources, some in the way they always were, some in complete new ways. And coal, oil, and gas are very recent resources. We have enormous amounts of oil and gas in the world. It's just a naturally occurring chemical or substance until we found a way to use it through technology and economics. The other thing is just to talk about limits, because I think I think the people use this different kinds of limits, and I find that sometimes in discussions I get people conflating with, well, what they're really talking about is a social limit. And things like, as I said, what I'm wearing today is a social limit. What house I can buy, at least for me, is an economic limit. And speed limits are safety limits, and how much arsenic I can eat is a health limit, and the speed light's a physical limit. And really what we're talking about in sustainability is the environmental limits. Not that these other limits don't exist for hydrocarbon usage or social limits and other things, but the issue today, I think, is to stay to what's the environmental limits. And so this is it. What if we could change that question about what the limit is from what the limit of production is to what if the question was, how can we change the environmental limit to the consumption of hydrocarbons? And that we can then bridge those two charts. Because hydrocarbons are only a resource because of technology and economics, and their impacts are a direct result of the exact same technology and economics. So just to give an example, I grew up in Calgary in the 1960s, just in case you didn't believe me that my career was half over. And the population in Calgary in the 1960s was 400,000 people. Today, it's 1.2 million people, and I can tell you from my personal experience, the air and water is much cleaner today. 3 times as many people with a total lesser impact on air and water quality than 400,000 people have. And and it's because we're wealthier. We're wealthier, so we can afford it, and we have technologies that allow us to do it. And just to give you a little bit more statistically valid than trusting my anecdote, because you may not have been in Calgary when I was in the 1960s like me, Environment Canada has been starting to shut down air quality monitoring stations. So before you get too panicky that there's budget cuts or that Harper somehow got involved, the reason is because they've been reading zero for so long. That they said, why are you maintaining these air quality monitoring stations that have been reading zero for as long as they have? So that's something that's more statistically valid, but I promise you the air and water is cleaner in Calgary today. So that sustainability of being able to meet human progress while at the same time sustaining our natural environment and reducing the impacts, to me, needs a new way of thinking. And I think we have to get away from incrementalism. I think we have to try to change the paradigm. And what convinced me is I had a guy from Los Angeles call me. He was a Dutch person from Los Angeles. He was a documentary filmmaker, and he called me. He said, I'm making a documentary on energy, and I'd like you to be in my documentary. And I thought, well, of course, that makes a lot of sense. And why don't you come and interview me? And so he does. And about 90 seconds into the interview, I realized that it wasn't actually about me. It was about Suzanne West. And Suzanne West is a person in Calgary who said, the whole problem with the oil and gas industry is an old way of thinking, and that we can produce oil and gas with zero emissions. And of course I thought, well, that's impossible. That doesn't make any sense. That's a physical limit. You can't do it. And that's what he wanted me to say in the documentary. But I said, well, before I say it, I'd like to meet her and understand just exactly what she's talking about. And what I found was a couple things. One is that what she was really saying is if we don't change the way we're thinking and start setting a goal of trying to change the paradigm, we never will. And that she did think that she could potentially, through new technologies, produce oil and gas in the boreal forest in northern Alberta with zero emissions. Now, sadly, her company didn't succeed and the idea didn't work, but it stuck with me that the only thing stopping her was a source of energy. Because the northern forests, it's minus 30, it's 6 hours of daylight, how do you get energy up there? But I realized that we had here a discovery in Quebec where we did have at hand, literally, actually, right over top of the land, emissions-free hydroelectricity. And so I'm just gonna see if this will work. I always get nervous at this point, if the video plays or not, but this is a project that we're working on relative to, inspired by that, Suzanne West. Okay, and the other choice that we are living today is business as usual, and business as usual is over 3 times the emissions than doing something in a new way. That's what's happening right now in Quebec, is importing natural gas with over 300% of the emissions globally than what doing a hydroelectric powered local production. And I can tell you that it is not technology and it is not economics that's holding back that. It's a social limit. And the social limit is opposition to hydrocarbons in general. And I want to just say something I think it's really important about activists and environmentalists, is that our society really needs these people. They are the ones that push people like me that something can be done better. They're the ones that push governments to make sure that things are being done better. And I would way rather have an alarm that goes off, a fire alarm that goes off when there's no fire, than one that doesn't go off when there is a fire. And so I also talk to all my colleagues. I don't think environmentalists even have to have the same requirements on their information. If they suspect or are concerned, then pull the alarm and let industry and government reassure people. I think that is the way it should work, and I think it works well for society. However, I do think there's a concern when people just start pulling the alarm because they like what it does for their donations, or they like to do it just for fun, because that does happen too. And I also think that there's a point where perfection can become the enemy of amazing. And I think we have opportunities to do some very amazing things today that are being blocked by the desire for perfection. And we, in fact, had protesters just at our conference on Monday who were protesting the idea of industry trying to do something new, just because we weren't going to be perfect. But what we were going to do, I think, is absolutely amazing. So I'm wondering, well, what if the activists have actually won after a generation or more? What if they've won and they just can't change their habits, or they don't know it? And what if industry really, has already got the memo about social acceptability and First Nations and emissions and our environment? And if we have, maybe the activists, having won, should be working for pragmatic solutions today, not losing their aspirational goals for the future. And we do have another environmentalist, just coincidentally on Monday, Elizabeth May from the Green Party, saying, hey, we do need to get to zero, but we can't wait till 2050 or beyond to do it. We have to start doing things today, like eliminating foreign imports, which are higher emissions than local imports. She's saying this is something we can do for the environment today, and she's 100% right. It's a pragmatic solution today without losing her aspirational goals for the future. So I think Canada has a chance to be a leader here. Industry embracing social license, First Nations, industry moving beyond doing the minimum it has to or incremental approaches to embracing the idea of working to achieve zero as best we can today. Public is, I think, more and more reflecting, rejecting extremism in personal consumption and political choices, and some environmental leaders like Elizabeth May embracing pragmatic solutions that will make a difference today without losing sight of their long-term aspirations. And I think a global approach, a Canadian global approach to reducing emissions by exploiting our environmental advantages, of which we have many, we're a world leader, is both here and around the world. I think we can change the limit for sustainable development. I think we need to, not just for hydrocarbons, but for all our energy choices. Thank you.
Well, good afternoon. I'm Robert Kleinberg from Columbia University and Boston University. Pleasure to be here at this session. And this session is interesting because there's 3 very different approaches to problems of energy. I'm sort of the tech guy, so I'm going to be talking about tight oil, low tech versus high tech. Now, this is a good place to start. Everyone is very familiar with these charts, I'm sure, from the 2019 Annual Energy Outlook of the Energy Information Administration. And it's the usual reference case and 2 side cases. I'm not going to dwell on this except to point out that in the reference case, which is on the left in blue, the horizontal axis is time in years going out to 2050. Vertical axis is oil production, a sum of tight oil and conventional oil in the U.S. And as of this year, we're producing something like 6.5 million barrels a day of tight oil, which is remarkable. EIA says it's going to be going up until early 2020s, next few years, and then sort of basically level out at about 10 million barrels a day. So that's the reference case. The high resource and technology case is the green case in the middle. And there we see rapid rise into the early 2020s, and then a almost as rapid rise all the way out to 2040 when the oil peaks out at about 14 million barrels a day. Looks optimistic. And then on the right is the low technology and resource case, where, again, we get sort of peaked out in just the next few years. It's something like 8 million barrels a day, and then it's like all downhill from there. So the question is, which one of these is right? The crystal ball is cracked and cloudy, and not even gypsy fortune tellers could really answer this question with any assurance, although I will say that gypsy fortune tellers have about as good a record as the EIA does in forecasting tight oil production. And, okay, well, we have representatives right here. Yeah. Okay, so the question is, which track are we most likely to be on? So first of all, let's start with low tech. What we have up here is a picture of Spindletop, drilled January 1901, blew out at 100,000 barrels a day. First well in East Texas, a gusher, as we say. Basically, the important thing about this is that Spindletop and all those gushers in the early days were produced on what is called primary production. And what that means is that all you do is drill a hole in the ground, depressurize the borehole, and there's gas dissolved in the oil, which upon encountering the lower pressure in the borehole, then sort of pushes out the oil. So it's a lot like a bottle of soda, or if you prefer, a bottle of champagne that maybe you've shaken up, got carbon dioxide in it, you pop the cork and whoosh, you get a whoosh of liquid along with a lot of gas. As soon as you run out of gas, the whoosh stops, liquid stops coming out of the bottle, and what you have is sort of flat champagne or flat soda. And unless you tip the bottle, that's all you're going to get. Now, you can't tip reservoirs. So primary production runs out really quick. So you leave about 90 or 95% of the oil in the ground. That's really all you get with these kinds of wells normally. And that is the way we're producing tight oil today. We're leaving 90 or 95% of the oil in the ground. That's low tech. So let's look at a little more detail. This is going to be a quick lesson in petroleum engineering to understand this process of primary production. The numbers here apply to a volatile conventional oil, Louisiana volatile oil. So the numbers are going to be somewhat different than tight oil, but the curves are all very much the same. The horizontal axis is fraction of original oil in place produced. So keep that in mind. Fraction of original oil in place produced. In this case, it goes out to about 25%. So you get about a quarter out of the ground. That's exceptional. The downward moving curve is a reservoir pressure that corresponds to the left vertical axis, which is pressure in thousands of psi. So you can see that you start at a high pressure with all that gas dissolved in the oil, and as you produce, the pressure goes down and down and down. Meantime, the upward curve is the producing gas-oil ratio in thousands of standard cubic feet per stock tank barrel, and that's going up and up and up as the oil is coming out of the liquid and driving the oil into the well and out of the well into your tank. Now you can see that gas-oil ratio continues increasing until you get to a peak. Once you get to that peak and it stops going down, game over. And that's all you're going to get on primary production. Like I say, in the tight oil case, 5 to 10%. Pretty pathetic. But this is a sign, you look at gas-oil ratio as a sign of we're running out of steam. Not steam literally, but we're running out of gas that's pushing the oil out of the formation. Okay, so what is actually happening today? This is from Bakken. And this is very typical of what we see in many of the plays. On the horizontal axis is time in years from 2013 to the present. Vertical axis, again, gas-oil ratio, 1,000 standard cubic feet per stock tank barrel. And the colored curves correspond to vintages of oil wells. So the black curve, which starts at 2013, is the 2013 vintage and its production history since 2013 to the present. The red curve is the 2014 vintage, which is all the wells drilled in 2014 and their production out to the present, and so on. And if you look at this curve and you're sensitive to steepening gas-oil ratios, this looks very, very scary, because what it looks like is that as time has gone on and we're getting to the more and more recent vintages, these curves are steepening. So one way of looking at this is that, oh my God, are we depleting the entire basin of this pressure that is built up with the gas dissolved in the oil? Are we just like blowing off all the gas before we get all the oil? So very worrisome. But remember, we've been to petroleum engineering class. So we're actually going to plot the data a different way. We're going to plot it on the horizontal axis as cumulative oil production in barrels. This goes from 0 to 200,000. Vertical axis, again, same thing. Gas-oil ratio, 1,000 standard cubic feet of gas per stock tank barrel of oil. And now this is a little bit calmer. The curves for the various vintages, same color coding here, 2013 in black, 2014 in red, and up through the spectrum into the blues for the more recent years. They're all kind of parallel, which is kind of a good thing. And although the 2013 curve is the lowest curve, the lowest gas-oil ratio, the highest curve is 2016, I believe. But 2017, 2018 are kind of in the middle, which suggests that there's really no systematic change in producing gas-oil ratio with vintage. What that tells you is that maybe each well is running out of, drive, producing all the gas, well goes flat. But as a basin, that's not happening. And that is a very, very encouraging story. You might remember a year and a half ago, there was an article in the Wall Street Journal which basically sent Pioneer stock tumbling about gas-oil ratio and saying, gee, we might be running out of drive in the Permian Basin. No, you just need to actually plot the data as a petroleum engineer would plot, and you find results which are a lot more encouraging. So what's actually going on here? Because we can see those, going back to the previous slide, something's happening. What is happening? Well, let's plot the data a different way. The horizontal axis is the months since initiation of production for each well, again divided into vintages, with 2013 furthest to the right, 2018 furthest to the left, and the vertical axis is cumulative production. These curves are interestingly different from each other. The 2013 curve, kind of lazy. It takes about 4 years to produce 165,000 barrels of oil. In 2014, about the same, but by the time you get up to 2018, we're producing 165,000 barrels on average from a well in less than a year, 4 times faster. So what's happening is that from a depletion standpoint, cumulative production standpoint, things are sort of business as usual, but those wells are being produced so much faster, which is a great thing for net present value, because you want to get that money back as soon as you can, and that's what's happening. These wells are being produced so much faster with much higher initial production because of super fracs, longer wells, tighter fracture initiation points, more sand, more water. It's what I call even more brute force. Crude but effective. And this is really the reason why those GOR curves are going so crazy for recent years. It's just because we're producing so much oil so much faster. So now I'd like to talk about future, and anybody who's ever been to any of my talks is familiar with this slide. Don't worry, I'm not going to explain every box, but the three different shades correspond to, in the light shade, primary recovery, the blues are secondary recovery, greens are tertiary recovery. This is basically the toolbox for production of conventional oil. It's been developed over the last 150 years, and it is very refined. Instead of getting 5 or 10% of oil out of the ground, we can get 30, 40, 50% of oil out of the ground by using these panoply of techniques in various combinations appropriate to the individual situation. All well and good. Again, this is conventional oil. What's the story for tight oil? And again, some of you already know what the next slide's going to look like. Oops. Not much here. We've only been producing tight oil for 10 years. The boom really started at the beginning of 2009. And we don't really have much in the toolbox. We've got primary recovery, which I've just told you all about, everything you need to know. There is no secondary recovery except for one field, the Viewfield Bakken in southeastern Saskatchewan, which is a complete outlier. We're just going to put that in the crazy Canadian file and forget about it. Aside from that, no secondary recovery of tight oil plays, no tertiary recovery of tight oil plays, until now. So back a couple of years ago, EOG, which is a premier tight oil producer, operating mostly in Eagle Ford, announced that they had some secret method for restarting wells that were running out of drive. In other words, they were being degassed, but then they were doing something to restart the production, and they were getting 30 to 70% more production out of a well. Now that's, wow. So that means you're going from maybe 10% of original oil in place to 17% of original oil in place. That is a super big deal. But they were being very cagey about how they were doing it. I think they were collecting leases where this technique worked particularly well, particularly in the Eagle Ford, but they were kind of secretive. So in the meantime, there's been a lot of curiosity, and finally, some people at Montana Tech sort of reverse engineered and figured out what the heck EOG was doing. So it turns out they are injecting gas into individual wells. The gas goes back into the oil that's left behind, repressurizes it, and then you stop the injection, you start producing. It's kind of like classic huff and puff that we know from the steam, heavy oil plays, used in Canada quite a bit, in Alberta. But this is now getting gas back redissolved into the oil. It's like taking the champagne bottle, pumping CO2 back into it, and then popping the cork again, you get another whoosh. And it turns out from this reversed engineered approach, and this is done with real petroleum engineering calculations, so it's not kind of cartoon or made up. You can sort of do this, you get another spike of production after a couple of years, shown by that second spike off to the right, and then you can keep doing it. Now there is a law of diminishing returns, but you could do it many times, and eventually you get your maybe 70% uplift, which is pretty nice. So once people started figuring this out, and I think these papers were really sort of a driver, then other people started doing it. Turns out, I mean, this is not a super cheap process because you have to compress gas. The compressor is a big CapEx item, as shown here in this photo, which was published just in the last month in Journal of Petroleum Technology. Compression's expensive, gas compression's expensive. Nonetheless, it seems like everybody and their brother has sort of jumped on board. EOG, the pioneer, has already done, that is the initiator of it, I shouldn't use the word pioneer. The initiator of this has something on the order of 100 wells that they've been doing this on, and quite successfully. So they are sort of full steam ahead. But now all these other people, the Chesapeakes, the Marathons, the Oxys, and the Continentals, are now sort of getting geared up and got pilot projects in various plays. Eagle Ford happens to be a good one, but also it's being tried in Permian, Bakken, and Scoop Stack in Oklahoma. Again, this is just from this month's Journal of Petroleum Technology, so it's kind of hot off the press. So this looks like a real interesting way forward, that we're not going to be leaving so much of our resource in the ground. And now I'm thinking more, I'm going to go with a high technology case. That's kind of what my gypsy fortune teller is telling me. So with that, I'll leave you with those thoughts, and thanks very much.
Okay, so Bob made my job a little easier. So I was asked to talk about the geopolitical context. And so I was going to talk a little bit about OPEC's dilemma and how this is all sort of coagulating into the price of oil, and a little bit about how the U.S. Administration sees the tight oil and how that is causing it to play out. So, interesting question. Bob mentioned the technology, and he's showing you that recoverability is actually improving, and this has caused a challenge for OPEC. In 2014, if you were to sit around, as I did at a European meeting, and with people from the royal families from different countries in the Middle East, they would explain to you that if the price of oil goes below $50, the shale will shut in and it'll be destroyed, and that's it. They'll have the market back. And people try to explain that wasn't going to be the case, and we now know it wasn't the case. And so this is a forecast from Cornerstone Macro that looked at the sort of Goldilocks effect. If at $50, maybe we don't get this giant boost in shale that was on the EIA slide that Bob showed, but at the kind of numbers that OPEC is putting forward as their target, whether that's $65 or $70 a barrel, you see how much higher the red line is than at a low price scenario. So there's a lot of potential for the shale to meet the market demand, and assuming that global oil use meets around the targets that the International Energy Agency is saying, this increase that could come from the United States, all things being equal, would be enough to meet demand every year for the next 5 years. So assuming there's no giant global recession, assuming that 5 more oil producers don't go under the way Venezuela did, as we have this incremental demand every year of 1 million or 1.2 million, 1.3 million, 3 million barrels a day, that can be met by the United States alone. So that's an interesting dilemma for OPEC. And because that's known, the U.S. administration has been very optimistic about what policies it can put forward in the international market, because the United States is going to be meeting all the incremental demand that is going to come from oil. And so I had to make this slide because when you go up onto the Congressional Hill to testify about U.S. production, it's hard for people to remember that, hold on, I can't see my own slide, that the orange line is the total amount of U.S. production in terms of global supply, meeting demand, which is the black line. So the way we're thinking about it and setting our policies is almost as if, we're the yellow block, but we're actually only the orange block. And so that has become a bit of a challenge for the market. And you've seen that because you have this inconsistent expression of the absolute influence of the U.S. production, which is, it's the marginal barrel and it's going to meet all of demand and we're not going to need any oil from anywhere else to balance the market. And yet, the second something goes wrong somewhere, the president is tweeting that OPEC needs to put more oil on the market, and there's some inconsistency in that, which I think this chart illustrates extremely well. But, as Bob mentioned, the interesting thing about the shale, and I take us back to my previous chart, is because there's this flexibility that if I start to produce a higher price, I'm going to produce more oil. Then, and a little bit lumpiness with, infrastructure, which should be resolved at the end of the year. You could have more oil come out if the price is high enough. So in other words, if I start to get the price signal, we start to move towards $70 because, there's some catastrophe in another part of the world and we lose production. There is this possibility that we'd see more U.S. oil. So what is that meaning for what we call the boom and bust oil cycle? And one theory, which we're setting out to discuss in a special issue of EEP, one of our journals, we're going to have a special issue on the oil price cycle. One of the questions is, given this phenomenon in the tight oil, and also other companies that are producing their satellite fields now because they want to mimic this idea of what we call short cycling. So I don't want to invest $5 billion and have the oil be produced 20 years from now on an MPV basis. I want to take that same $1 billion I might have invested even if I'm Exxon, and I want to invest it this year and have the oil start to be produced this year or next year or the year after. So even if I'm not putting all my money into the Permian, which now Exxon and Chevron are, 50% of the wells being drilled in the Permian, maybe in the U.S. Gulf of Mexico or off the coast of Africa, I'm still doing like satellite fields, and so I'm investing today, and the production is still within a 2 to 5 year window, and not a 7 to 10 year window, which was the normal practice of industry. And so if you think about it, part of the stickiness for the oil price cycle was demand would rise. We'd have a booming economy. Demand for oil would rise. Companies would get the signal to invest, and then we would have to wait for that oil field to be developed. And in some cases, that we're talking about multiple years. Even in the case of an OPEC country, Saudi Arabia, Venezuela, we're talking about 5 to 10 years. So what that meant was the amount of revenue and rent that could be collected by an oil producer once they made the capital commitment could be very large, and it could last for as much as a decade. And so you had a tremendous transfer of wealth from oil-consuming countries to oil-producing countries that has characterized geopolitics. So I posed the question, if new oil could be brought online in a 3-year window, or in the case of shale, in a 6-month window, what does that do to the cycle? Because in the last 2 years, we've seen the price of oil go up and down in what might have been a cycle over a decade in the past, but it's happened like this year when we saw the price go to $70. Was that the top of the cycle for that part? And now we're going to go down, and once we go down, will the price go back up? And that's, again, another part of the cycle. So the question is, are we shortening a cycle because of the flexibility of shale and short cycle investment by the majors? And what would that mean? I add a fact to that. Over time, this abundancy effect and the speed at which we can produce, what Bob has already demonstrated, is actually going to intensify, which Bob did not talk about, and that is because technology is going beyond the kinds of traditional technologies that Bob talked about. So as I lower cost, maybe I'm going to lower cost. I was at a meeting last week in Houston, and there were some technology providers at the meeting, so they're speaking off the record, so I won't say which companies, and they were saying that in the next 5 years, the U.S. industry might be able to lay off 30% of its workforce upstream in the oil fields through automation, which is just bone-chilling. But if you think about the high cost of personnel as a function of onshore production, the idea that you could even lower it 10% would be a huge cost savings. And then there are all kinds of different operational automation that's going to continue to lower it, and then understanding reservoir through new sophisticated modeling and data access and so forth. All of these things you can see here, Cornerstone's macros estimates and EOG's estimates for how much of the cost could be pushed out of the barrel through these different means. So we're talking about a real cost reduction from a number that was already, fairly low. Exxon announced that its current projection for costs in the Permian is $15 a barrel. So if you were to go 15% below that, you're talking about a really low number. And to put in context for those of you who don't track the shale very closely, the whole competition between Chevron and Oxy to buy Anadarko was that part of the way to get the synergy and get the most bang for your buck from these technologies that are coming is to have contiguous acreage. And so both Chevron and Oxy wanted to grab the contiguous acreage of Anadarko, and that's why they got in a bidding war over it, because it was very valuable to have continuous formation that you could just apply the same infrastructure and economies of scale for this technology. So, what does that mean for oil-producing states? One of the things it means, and we can talk about OPEC in the Q&A session, I'll throw out some thoughts about that too, but one of the things it means, which is a big critical thing that I feel is getting under-discussed, is that over time, these national oil companies would get this giant surplus of funds through this 5 or 10 years where they're going to be having rent seeking and they're going to get this revenue rent. And it's true, they had to share it with their governments, and we can talk a little bit about that in the Q&A, where you had Venezuela's, raising bonds against PDVSA and, doing these different things that eventually led to the demise of their sector. But the primary thing I want to convey is this problem. So Venezuela kept borrowing against this national oil company, but it had very mature fields in the area that the oil companies, the foreign oil companies, were not involved in. They had a 25% decline rate naturally, which was not happening because they were spending $3 to $4 billion a year to hold that production flat through some of the methods that Bob threw up on his slide. So they were able to do that because after prices collapsed in '98, then they had many years of very high oil prices to put together some money, and even though they were spending a lot of money on non-oil activities, there was still enough money to spend that $3 to $4 billion. So in a world where the cycle shortens, even if we go up to $100 for a month or 3 months, if we're only going up to $100 for 3 months, and then we're coming right back down, that's not going to give these national oil companies the time to amass the kind of funding they need to do what they need to maintain their fields. And this sort of map of the world kind of shows you places where budgetary constraint is already showing a sharp decline in production. And I would add that you might be able to add that we have to worry about adding more countries to that list. So take Russia, for example, which has, very promising reserves and their production has been going up. One of the things that's going to happen in Russia is that they're going to have difficulties from permafrost melting. That's going to affect facilities. You're going to have other kinds of political trends in countries that have had corruption scandals and so forth. So the ability of national oil companies to maintain the budget and capital to spend in their oil fields could be a major challenge. That takes me back to this slide, because we're not replacing all of that from the Permian, and we're acting as if that is going to be a permanent trend. But there could be this sort of treadmill effect that doesn't come from the way people talk about it. When people talk about the industry spending capital, they look at the numbers for how much money Exxon is spending, and they say, look, Exxon isn't spending capital. And what I say to that is, Exxon and the big companies wasted a lot of capital investing in things that didn't pan out. LNG that didn't come to market, Caspian production that didn't come to market, Saudi gas initiative that didn't come to market, might come to market now in a different way, but didn't come to the market from the majors. Venezuela hasn't worked out for the majors. So there's a lot of, billions of dollars that were spent that did not produce oil production in the 90s. But today, they are producing that capital effectively, and you're going to see, I think, very high production from that private capital. To me, what no one's talking about is what happens if Iran's production goes so low that their fields are damaged because they're gas-driven fields and they lose pressure. We already know what happened in Venezuela. We know what's happening in Libya, right? When you look, you kind of do the tour around the world and you think about Pemex and some of these other national oil companies, you can understand that the risk actually is actually from whether there'd be enough capital for these national oil companies. So that's my provocative statement for our session. And now where I'm going to sit down and we're going to have a discussion, I'm going to ask my fellow panelists a few questions, and then I'm going to open it up to you, the audience. So Michael, hold on, I have to put on my microphone. So Michael, given what Bob and I have said, how do you see the sort of climate and sustainability question fitting in with this challenge of, where is the supply going to come from, and what is the nature of those players' ability to produce their oil and gas in a sustainable way?
Well, I think what makes it really interesting is to think that when I was in university in 1982 trying to decide on a career, that I thought that there was no chance that we'd still even have oil left in the world by this time. And you listen to this and it looks like there's almost no chance we won't have oil left in the world for quite some time. So I think that the one interesting thing to listen in terms of the technology and you were talking about some additional technologies as well, just how amazing, or maybe put another way, so the oil and gas industry is more high-tech than high-tech, and I think the one thing that people don't understand is just that in the end, oil and gas is competing extremely strongly with alternatives, who are also making amazing advances in technology at the same time. But we have this sort of idea that there's the new alternative energies that are high-tech, and then there's the old industry that's depleting away, and it's just the opposite. Oil and gas has been incredibly effective at employing high-tech to stay extremely relevant in our energy diet. And I think what I was talking about was that, how do we get those technologies to be also focused not just on being able to create more resource out of things that never used to be, like tight oil and tight gas was not a resource even 15 years ago. That's all now resource today. How do we manage to make that technology focused also on the impacts it's having?
100%. And we're seeing that in the Permian and some of the places in terms of people automating their water systems so that they don't waste any water, and the capability now for methane capture because of the Colorado rules are producing all kinds of new technologies that allow companies to produce without actually methane leakage, which not everybody's embracing but could be embraced. So Bob, thinking about this sort of technology piece and thinking about the sort of risk that I laid out for national oil companies, how hard would it be to get the national oil companies to also adopt all these new technologies, both for sustainability but also for productivity? And will that make a difference in having oil continue to be ample?
Well, that's a good question, and if we think about Venezuela is really is sort of the poster child really for your question, because back in the 1990s, we at Schlumberger were working with PDVSA, and they were an amazing technical partner. I would say some of the world's best petroleum engineers were Venezuelans working on Venezuela tight oil fields in the Orinoco River Basin and so on. And then due to political issues, basically that technical capability was destroyed. Those petroleum engineers left Venezuela, moved to Canada, much to Canada's benefit. And they might not be coming back anytime soon. Probably not. So I think that the governance issues are actually more important than any sort of domestic capability issues. Pemex is also kind of very problematic. The Mexican liberalization of a few years ago was really a very important initiative of the previous Mexican administration. It was extremely unfortunate it coincided with the collapse in the oil markets. That was, unfortunately for Mexico, sort of a world-changing event for them. And now the new administration seems to be backtracking. So really, I'm going to throw it back to you that I'd say governance is probably a bigger problem than technology. Technology will diffuse pretty readily around the world if people are ready to take it and invest in their resources, their oil companies, in an appropriate manner. If they don't, then it's kind of disastrous.
Okay, well, on that note, let's open it up to you, the audience. I'm hoping we have some questions, so we have plenty of time for discussion. Go ahead.
Thanks. I never had oil engineering class.
So can you, let's do a thing where you just identify who you are.
Okay, my name is Werner Hediger. I'm from Switzerland. I'm a pure economist, doing some work amongst others in energy. And I have a career of doing work on academic issues and sustainable development for more than 30 years. So you provoked me with sustainable hydrocarbons, the idea of sustainably producing oil and gas by the companies. I don't know an oil company or gas company producing oil or gas. They're just taking out what nature has been producing. I'm also an ecological economist. Sustainable hydrocarbons would mean no oxidation of hydrocarbons. So what we are doing for the next, or have been doing for the last decades, is the most stupid thing, I guess. We are burning a highly valuable and essential raw material before using it. It's oil. So we might look at it differently from with gas, but I would suggest to change the questions. I learned also this afternoon, change the questions, change the mindset, and I want to be a bit provocative with that. Can we have different questions? What is the future if we would change our mindset towards something which we could call contribution of oil and gas, or especially oil or hydrocarbons, to fossil fuels, to sustainable development? Maybe not as an energy carrier, but as a raw material. I hope I'm provocative enough.
Okay, Michael, you want to take that one?
Yeah, well, we talk about here in Quebec, there's a, did I lose my mic? In Quebec, there's a strong policy, and I by 2050, I won't likely be here to know whether it gets carried through or not, but there's a strong commitment to not using fossil fuels by 2050 here. And I've talked to the Transition Énergétique Quebec people just about the point you've just raised, but natural gas is used for a lot of things. And this is the one thing, and oil as well. I mean, if you look around you, and first of all, everything comes out of the ground. Let's start with that. And second of all, a lot of what you're wearing, using, technology, hospitals, hydrocarbon-based products are everywhere. They have this amazing advantage that they're made, organic chemistry is a pretty cool thing. You can make things out of oil and gas because it's made out of the same thing we are. And that's why you can make artificial hearts and artificial knees and put it inside your body. It's made out of this contact lenses. It's all made out of the same stuff we are. It's amazing, unbelievable product in that sense. But so 2050, let's assume we don't use natural gas in Quebec for fossil fuels anymore. Let's assume that the policy is successful. We will still need fertilizer, and we will still need chemicals, and we will still need methanol and LNG and other products like that. And my point is, I'm the producer, and that's why I talked about changing the question to the consumption. If we can produce the product with zero emissions, then the consumer can decide whether to use it as fossil fuels or create methanol or other chemicals as a feedstock. And what I know, whatever the consumer decides, we will have provided it with the lowest possible emissions to create the cleanest possible fertilizer or methanol or fossil fuels, depending what consumers decide to do. So I would embrace what the the gentleman said, that we, around the sustainable use and consumption of hydrocarbons, I think fits into a future world that we just need to produce it with the lowest impacts.
And I'll just take on that question from the standpoint of the fossil fuel industry, which I was, employed by for the last 40 years. Basically, there's sort of two responses. Assuming that we do continue to need fossil fuels, if only to take up the slack when the renewables and intermittents are not available. The two responses are, firstly, the internal operations, and those are, decarbonizing internal operations is the sort of problem that oil companies and similar engineering companies like, because it's an engineering challenge. We can limit methane emissions. We are sort of on the road to doing that more effectively. It's a very interesting story. We can make refinery operations more efficient and so on. In the end, most of the carbon that's put into the atmosphere from the fossil fuel industry is because of you, the consumers, using the product. Somebody mentioned, I guess as you mentioned, you've stopped taking oil out of the pipe, we'll stop putting it in. And from that standpoint, the response of the fossil fuel industry is, yes, let's try carbon sequestration. It's talked about all the time. I'm just going to provide a couple of numbers that are relevant. Schlumberger looked into this as a business. I was one of the people on the committee that recommended to our CEO that we implement it. And Schlumberger decided it could take carbon dioxide, pure carbon dioxide, delivered to the wellhead and sequester it safely for about $10 a ton, which is pretty low cost. It's within sort of social cost of carbon, $20 to $40 type numbers. The problem is the chemical engineering of the capture. And so I've been going around telling university groups, you need to be studying chemical engineering because that's $50 a ton to capture the carbon out of a flue gas and so on. And if we can drive down that number, then sequestration actually becomes more than just a talking point and something that's on a cartoon slide. But that's what's going to really be needed.
I just want just one further point. The presumption in that last question was we only have this little bit of oil and gas, and why would we waste such a valuable product? But the reason I put that slide in about what is a resource was to exactly answer that. The amount of natural hydrocarbons that exist as a natural substance in the earth is beyond comprehension, and I don't even know how we could possibly use it all. You were talking about reservoirs. We're only getting 10% of it out. That means 10% of it's a resource. The other 90% is just a natural substance in the ground. It is not a resource. So the idea that we're going to run out of oil and gas, I think is I mentioned I had that idea in my head in 1982. Well, believe me, I've changed my mind. We're not going to run out of the natural substance. It's only a question of technology and economics that turns it into resources, and there's just no practical limit to how much natural substances exist. So I just would make that point. The idea we're going to run out when we talk about sustainability is just is misthinking.
Right, so I think the point is when one thinks about the energy system and the energy complex, one has to decide what is the technology path forward, either to use oil and gas without emissions or to shift to other technologies that don't have emissions. And what is that path forward, and what is the pace at which we have to do it? Because it's not going to happen in what I call the Al Gore way, which was, he used to say in 2000 that we're just going to run out of oil and it's going to become so expensive that we're just all going to stop using it because it's just too expensive to use. That is not going to happen. And so what we're really looking at is a policy that would be a purposeful policy, that is an emissions-based policy that would drive emissions out of our daily activity. Next question.
Thank you very much for a very interesting presentation, and it's very close to my topic and my theme, and I have particularly the question for you. I answered a couple of times here already, but still have no quite informative answer for that. So how does the situation with this associated gas in the Permian Basin, which is now burned due to this pipeline restrictions, and we're still waiting about some news about these 3 pipelines. Now is in progress, and there is no information about whether they will be constructed or not. So I'll be thankful if you will have some kind of very updated news about that. Thank you.
So I guess I'll start. So it's a very big challenge and becoming a bigger challenge because of the trade war. So I do believe that there are pipelines that are planned, but really the key thing is not so much the infrastructure, but where is the demand? So how am I going to use that gas? Is there enough demand for the gas and electricity? So the story I like to tell, which flows in from our last questioner, is very important. 5 years ago, the plan for the Permian gas was the hope that the El Paso pipeline to California would be expanded, and some of it was going to go to California, and some of it was going to go to Mexico, and some of it was going to exit as LNG to China. Now, why is that not actually going to happen? That is not actually going to happen because a company called Sempra had an accident in California at a natural gas storage facility. And it caused a panic in the communities around that facility. People were on television in California crying for over 12 months. People were very sick from this accident, and as a result, it's ratcheted up. The first result was that when Sempra went to Sacramento to tell the governor and the legislature that they had to be able to put the facility back on and we'd have electricity shortages in California, the big players in battery storage came running to Sacramento first. They went to the city of Los Angeles and some of the other big places that would have had the blackouts, and they installed 105 megawatts of solar and battery storage in 6 weeks at a commercial price. Okay? So my point to you is, now California is saying if they would make a pact with the Northwest with hydro, they can get to 100% renewables. And so the market for natural gas to go from Texas to California is going to shrink, not the other way around. And as China has identified battery storage and solar and all those technologies to be part of its industrial policy, China 2025, I know that everybody in LNG is counting on China to be its customer for this natural gas or some other natural gas because we're having a trade war, and then our gas will go to that other person or other country. The issue that I see, and I'm not making this up, I'm not original, so I'll quote the person who first said it. There's a guy at S&P Global who's a top analyst in LNG. His name is Ira Joseph. And I was going to give a talk in Qatar, and I'm like, oh, let's talk about my talk. And he said, you need to make the point that China is not necessarily a customer, they're a competitor, because they are going to be the largest exporter of batteries and solar panels. And so I really do think there is a big question for how will US companies create demand for their natural gas, and the answer is it's going to be very hard. And there are sustainable things you could do. For example, in California, the state is looking at mixing natural gas with renewable natural gas, so natural gas that's coming from landfill or agriculture, and therefore you can clean up putting natural gas in trucks to some extent where you're getting a benefit away from the emissions of diesel trucks. So, I mean, it's going to have to be some creative solution.
Or probably some maritime fuel as a maritime fuel.
Yeah, possibly maritime fuel, right? So it's going to have to be that the natural gas industry is going to have to look in the mirror, and instead of funding campaigns in the United States trying to kill wind power, which is what Continental and some of the big shale companies are doing, they need to look in the mirror and think about sustainable markets where natural gas can be a cleaner fuel, especially by capturing their methane to clean it up.
I just like to add, I think that the real low-hanging fruit right now in oil and gas is venting and flaring regulations, and we've seen Colorado make a huge step forward and probably become North America's leader where Alberta used to think it was. Probably Colorado is. So I think that's a low-hanging fruit. Make that point. And then just to plug our project, we're making the commitment, this is not a difference in technology, it's just a change in attitude. We're making the commitment to have the sales line installed before the wells are drilled so that we don't vent and flare. We'll test the lines, and we will, and then again, the rest of the story is around vapor recoveries, et cetera. But I would just get back to that. I think you can regulate these issues to say, well, you just can't produce the oil unless you have a way to deal with the gas.
Thank you very much. Yes.
My name is Adam Semensky. I'm the current president of CAPSARC, the King Abdullah Petroleum Studies and Research Center in Riyadh. I was the administrator of the Energy Information Administration for 5 years. Bob, I know you're being friendly, but EIA is one of the few organizations in the world that actually publishes data on what did go wrong in their forecasts. And it is available freely on the EIA website, as Guy Caruso can testify. My question actually is not for the panel here. My question is for the first questioner, and I'm not sure where that gentleman is. Do you believe that Michael Binnion was trying to deliberately mislead us with his graph showing the relationship between energy consumption through carbon dioxide output and improvements in poverty, the decline in poverty? I've seen similar graphs on infant mortality, adult life expectancy, diseases. If you think about what energy did bring, the first industrial revolution, coal and steam, which allowed textiles, clothing, affordable. Second industrial revolution was electricity and gasoline. Powered vehicles, diesel-powered vehicles, internal combustion engine. Third industrial revolution, computers. The fourth one, which we're kind of in now, is information technology, big data, but you still need energy for this. And I think Michael did say that, and I agree, everything that EIA has done shows this, is that we're not running out of hydrocarbon supply. The fear currently is we're going to run out of hydrocarbon demand. So I'm back to the question of, do people really believe that there is not a relationship between the availability of affordable energy and the improvements in health and technology, health and welfare income that we've seen? I'm really puzzled by that question. So I'd welcome comments from the panel, but I'd also welcome hearing more from the first questioner. Thank you.
I'd like to add to your list equality. We live in a world where there's incredible equality compared to any civilization before us, and the simple reason is because energy and technology does our work. And before this, I mean, if you want to go to enlightened societies, the Greeks, the Romans, Egyptians, any enlightened society before this didn't have running water, they had running slaves. And it was because they didn't have machines and energy to do the work for them. And I think that to realize that all of us today, why were 90% of people poor in 1800? Because you had to do manual labor. And the world's changed so much. We have unbelievable opportunities. It's not just that we live longer. It's not just that we have less disease. It's not just those measurements. It's also the ability to have an amazing life and to have such great equality. So I just want to throw that out there, that it makes such a big difference in all of our lives.
So I was thinking about the 800 million people that still don't have reliable electricity. Okay, so that was kind of a rhetorical question, the first one. Amy,
I answered it anyways.
If you're right about the cost of, if Exxon can really do oil in the Permian Basin for $15 a barrel, and if the Permian Basin is going to supply all of the incremental oil for all of world demand growth, then I would suggest that we should all start studying what the world looks like at $15 a barrel, because that's where we're going to be headed. And the geopolitical issues associated with that might be pretty ugly.
Well, and I think that's sort of the point of my talk, which is that it's not a 100% sustainable condition in the sense that you're seeing it already, right? And I written an article about it, which you can all look at online. It's called The Tech-Enabled Energy Future, because unlike the rest of you who are just pontificating about the beauty of oil and gas, in this new digital age, I think our ability to produce energy and use energy in ways that means we don't need as much oil, or we could purposefully choose not to use oil, is going to be stronger and stronger. We have the potential to do it. And the question is, for our first questioner, is do we have the political will to do it? Because we are going to have the technology to eliminate demand through our own behavior. And the question is, will we choose to do that? You know, if you look at what happened in 1905, you know, we made certain choices, and we have that same infrastructure 100 years later. So now we're going to come to a new infrastructure potential that's going to be digitized in our homes. We're not going to be driving our cars. You know, we're going to have all these different capabilities for automation. And the question is, are we going to use that automation to increase oil demand because we're all going to be hitting Uber and it's going to be a gasoline car? Or are we going to use all that technology to have systems for getting around that relieve air pollution and congestion and so forth? I think that's an open question, and that's a generational question, right? So, but on the outcome, you know, this is what I tell people. I'll use Russia as my example in deference to the fact that you're based in Riyadh. So we had this problem in NATO that Russia was using, we can debate it, but my opinion is Russia was using energy as a lever, as a geopolitical lever, right? And you can see, you know, you know, turn on the TV and hear about our molecules of freedom. You know, President Trump is playing up how U.S. energy can reduce this dangerous lever, right? Well, you know, the problem with that is it's actually working, and there was a great presentation at Columbia by Tatiana Mitrova, and I were on a panel together, and we got in a big debate because her contention, which I think is correct, is that part of what made the Russians unpowerful was not so much U.S. LNG coming, because it hasn't happened that much yet, but actually the installation of renewable energy all around the EU, right? Really reduced Europe's, and even if it didn't reduce the actual market for Russian gas, I know what I would do if I can't use Russian gas, because I'm going to put more of this technology in, right? And I know I have the technology. So Russia can help me create the political will to switch to more renewables and figure out some software battery solution to the intermittency, right? And aggregate, like we're doing in South Australia, my batteries through all these different houses, and then the PUC can move it around or end demand in a particular hour. I mean, those technologies will be developed further if I had to, because I can't rely on Russian gas, right? And that is resulting in lower and lower numbers for Russian gas, on top of the fact that it's also lowering the price for LNG. So what has that meant for Russia? It has meant that this semi-soft power tool of sort of just hinting that I might have a problem with what you're paying for my natural gas has been converted to hard power. We're seeing Russia much more adventurous with its military and having a military buildup. We're seeing it moving its submarines around Scandinavia and other places in the waters in a more aggressive way. We're all sitting here in the United States talking about, well, here in Canada you're not, but in the United States, we're all sitting around talking about Russia hacking our elections, right? So we're seeing some really dystopic results from the fact that there was a period of time where Russia felt it was powerful because of its energy petrol rent, and now it's not, and they have to revert to something else. So I think there is a possibility that all these freedom molecules, whether they're renewable freedom molecules or whether they're American freedom molecules, are actually raising the temperature for geopolitical risk emanating from petrostates. And I don't know how that's going to play out. I think it's going to mean oil prices are going to be volatile, but I agree that Exxon being able to produce at the Permian at $15 and you know, Cornerstone Macro, if you've heard them give their talk about the abundance that comes behind that, because the idea that the Wall Street Journal has put forward that somehow there just won't be enough capital to produce this resource. The resource is there, it'll change hands to somebody who has the capital, and it'll get produced.
Just a very quick comment. In this community, it is a cottage industry to make fun of the Energy Information Administration, but the people making the jokes, including myself, are also the most avid and respectful users of the data and projections. And I think many of us understand that, and Adam and Guy, you certainly have my full support for that agency, which has really been a marvelous resource for us, for us all.
And it's a critical agency, and all of us who work in this industry together need to do what we can to protect this data, right? And make it continue to be publicly available and make sure that it is accurate data, that is not politicized in its release, right, or its collection, because it is the basis for which policy analysis is done. And it's a critical element. I will tell you the truth that because of some of the controversy about climate science in the United States, there was a team of people at the University of California that downloaded all the publicly available information that was on like EIA's website and NOAA's website and so forth to preserve the data. Because we all take for granted that this data is available online. But what if tomorrow some authoritarian shut off the internet through an attack? How would we restore the data? The data would become instantly unavailable. We don't print it in books, right? So it's really, we joke about it, but it's really a serious issue, and it's an important issue for this organization. So we're kind of out of time. I'm going to have our one last question because the gentleman's been very patient. And go ahead, last question.
Okay, thank you. Thank you for your presentations. I really have learned a lot from hearing all of you speak. My question is in regards to the first presentation on sustainable hydrocarbons and the video that was in it. Both the presentation and the video alluded to certain projects in the oil and gas sector striving to be zero emission producing projects. And I was just hoping you could kind of clarify what that means. I seem to have some fundamental confusion on what zero emission projects would mean, because in Canada at present, the oil and gas sector represents something like 1/3 of all emissions at present. So I was hoping in a tangible, concrete way you could allude to what a zero emission project within the oil and gas sector means. Thank you.
Right. Well, let me talk about three things that are just three live examples right now in Canada. One is that the oil sands have gone from the 90th percentile in terms of emissions intensity, and I don't mean the 90th best, I mean the 90th worst. I mean, they're only Nigeria and Huff and Puff in California, I think, were places that had higher intensities. And the new projects coming on in Alberta today in the oil sands are now coming on at 50%. The 50th. So that I look and say, what other country would you want to trust with a resource like that would make that kind of progress? And what I would say is it comes because, as I mentioned, I think industry in Calgary, at least, under a lot of social license pressure, which I'm giving credit to environmental movements for helping to create, has just said we have to take a leap forward. And I think what's happening in the oil sands is an example of a leap forward for the type of resource and the progress there. The other one is the new LNG Canada plant that's planned for that has the go-ahead now for Western Canada. Benchmarked against LNG plants around the world is expected to be 50% of the average emissions per ton of LNG. So a lot of people talk, oh, well, LNG is going to replace coal in China. Well, don't even worry about that. All it has to do is replace other LNG, and it'll drop emissions by 50%. And then the project that the video is about was one here in Quebec, where it's saying let's electrify the entire process. And probably 80–90% of the getting to zero emissions is by saying that the rig is going to work off the highline power, but so will the pumps, so will the pump trucks, so will the dehydrators, so will the compressors, so will every piece of equipment work off the highline power, and that will then take, I said, about 80 or 90% of the emissions per MCF of gas out, and the balance comes from the thing I referred to earlier of making a change in the development, just the order of development, that sales lines are brought first, and all testing is into pipe and not to atmosphere. But also it involves 24/7 electronic monitoring of pipes and for fugitives and leaks. It involves advanced vapor control systems to gather vapors and either recompress them or otherwise deal with them. So it's a number of things to get to what we would technically call near zero emissions. But we're, as I said, confident that it's not a technology issue. It's not an economics issue. What would block us from achieving that zero emissions production here in Quebec is more a social issue.
Thank you.
Okay, thank you very much. Well, I want to thank the panel and for our great questions from the audience, and a very successful session. Thanks very much.